variables, and we can use a scatter plot to determine whether a linear or straight line correlation exists between two variables. For example, if we have a list of x's and y's, then a scatter plot would be graphing them like you did back in algebra. X is 1, y is -4. Means we go over 1 and down 4, so this first point corresponds to 1, -4. 2, -2 would be over 2 and down 2, so that's this point. So the data values given in this list create a group of points, and those points sometimes have a relationship in that they approximate a straight line. If they approximate a straight line, then we call it a linear correlation. So here are some linear relationships and the sample correlation coefficient. Okay, this is the title of one of your ALEKS topics. So here is a group of points that have a negative linear correlation. As x increases, y decreases. A positive correlation would be as x increases, y also increases. Sometimes there's really not much of a correlation. They're just sort of all over the place. And occasionally you'll find an actual nonlinear, some other shape to the correlation. We will limit ourselves in this course to linear correlations. So that's essentially a negative, a positive, or a no correlation. In a negative, as one increases, the other decreases. And positive, they both increase together. And no correlation, they're sort of all over the place. There's a correlation coefficient for every set of data. There's a humongous formula that gives the correlation coefficient of that data. It ranges from -1 to +1. If R is the letter that's used, is -1, that would mean there's a perfect negative correlation. It goes exactly in a straight line down. If R is close to 0, then there's no correlation. The points are all over the place. And if R equals 1, then that would be a perfect positive correlation in an exactly straight line going up. Regression lines would be a line that we draw through the points, the purpose being to get the distances of all these points from the line to be as small as possible. So if I have 3 points below the line and 3 points above, their distances essentially cancel each other out, and so that would come out to a pretty small difference, the difference between the points and the line. Well, there's a ton of calculations involved, after which you would find the line of least squares. So the best fit line is called the regression line. And we can use that line to predict the value of y for a specific value of x, even if there wasn't a point using those numbers. So the regression line is a line through the points which minimizes the sum of the squares of the distances between the points and the line. The equation of a regression line for an independent variable x and a dependent variable y is y hat, which is the predicted y, equals slope times x plus y-intercept. Remember this from Algebra 1. The slope is m times the letter x plus the y-intercept is b. And then we can predict a y value. If we put in an x, we can use this multiplication in addition to predict the y value.